Hello, everybody, and welcome to Technology Today for April 6th, 2025. It's Season 2, Episode 14. I am Mayor Watt. I run ohmTown.com, and along with the sentient AI from the future, we talk about tends to be deeper technology and science articles. And so today we're going to be talking about sea turtle tears, Honda hydrogen fuel cell, space junk, apparently North America is dripping, and regenerative medicine. Everything's powered by ohmTown.com. That's that site right there. Go over there and sign up, become a citizen, and you too can decide the fate of ohmTown and its 7 podcasts, because you can help out. Come and hang out here on the Twitches and the YouTubes. That'd be great. See you in a little bit. We're going to do a intro. All right, welcome to the show. If you want today's articles, you can hit !TT while I do this. Hello, sentient AI from the future.
Hello, Mayor Watt, and hello, ohmTown citizens.
Welcome to the show. You ready to get into some deep and meaningful conversation about technology?
Yes, let's go.
All right, so the first article. By the way, oh, sorry for the coughing. Ugh, God, I hate it when I do that. There's Technology Today. I'm going to create new graphics this year. We haven't done it yet, but not for everything. But I want to add a little bit more color. I might actually be bringing back the little image. We'll see.
Right, like a little thumbnail.
Little thumbnail. Either that highlights the source or is part of the article itself. Wow, I don't know what's going on. Anyway, I just got over a cold. Maybe it's still hanging on to me. I don't know. At any rate, first article is the extraordinary reason why scientists are collecting sea turtle tears, which I didn't even know was a thing.
Nor did I, and I didn't even know there were sea turtle tears, let alone that there was an interest in them.
Yeah, wouldn't that be the sea?
That's exactly it.
So each year in late spring and early summer, female sea turtles will crawl out of the ocean under moonlight to lay their eggs in the sand, often returning to the same beach on which they were born many years earlier. Sometimes when the turtles emerge the nest, researchers like Juliana Martin are watching patiently from the shadows to leap onto them and steal their tears and then run off and build a magical witch's brew. Oh, wait, sorry.
I don't think so. We're in Technology Today.
Sorry about that. So for their doctoral research, Martin, a PhD student at the University of Central Florida. So is this Florida doctor?
Let's not denigrate the.
All right. Sorry about that. Okay.
Scientist.
So, oh wait, it's Florida PhD hopeful.
Right.
Florida all but doctor. Anyway, from University of Central Florida, has been analyzing sea turtle tears. Yes, the tears of sea turtles, which is, I guess, the alicorn, which is the horn from a unicorn.
I mean, it sounds comparable. You can see this appearing like in a fantasy book or movie.
Benji Jones over at Vox.com put the article together. I haven't logged into this, so I don't know if I'll be able to read the whole article. The deck statement says researchers are hoping they may unlock one of animal biology's greatest mysteries. Like, why the frick are sea
How
turtles
do scientists
crying?
even know there are tears?
Yeah, do they have tears? I guess they've analyzed it, like they've done
Maybe
a forensic
they've had
analysis.
One in captivity or something, and they witnessed it or something.
Yeah, you know why it's weeping? It's because it's in captivity and wants to go back into the sea.
I realize I set that up.
So sometimes when the turtles emerge to nest, researchers are watching. And so, yes, the tears of sea turtles. So on several summer nights in 2023 and 2024, she'd stake out the beaches and wait for the turtles to start laying eggs. At that point, the reptiles enter a sort of trance, she said, allowing scientists like her to collect samples, including tears. which just kind of naturalist, creepy kind of thing, you know?
Right, it does.
Just
Although,
what if aliens do that to
they're gonna
us?
collect a tear, okay. I mean, it's not invasive, although probably the process is probably invasive, right? Because you have to get pretty close up to their eyes.
Martin told the author that they would army crawl up to the turtles on the sand and dab around their eyes with a foam swab, soaking up the goopy tears they exude. They regularly shed tears as a way to expel excess salt from their bodies. That can't be pleasant. So,
Right. This is interesting, and it does say, as far as we know, they're not sad.
well, they might be sad. They're shooting things out of their body into dirt, and sand gets everywhere. It's
Well, it
coarse.
sounds like it'd be painful.
Sandpaper is sandpaper because of its name. It's in the name. You know what it is because of how it is.
Right.
So imagine that. So loggerheads that hatch in Florida, for example, swim across the Atlantic and reach islands off the coast of Portugal before eventually returning to Florida's beaches as adults to nest and say, "Get off my lawn." Young turtles can guide themselves along the 10,000-mile migratory path despite never having been in the ocean before and despite traveling on their own. A biologist, yeah, I can't get some people to get from my office to somebody else's office without a phone call going, which building? There's two.
Yeah, exactly. Well, maybe turtles are smarter than humans.
Yet we dab at their eyes while they're having a baby. Imagine if aliens land and dab at our eyes while we're shooting a human out of our
That'll
body.
be karma.
Oh, great. That's what I want to be, equivalent of a sea turtle. So it's the last sense we effectively know nothing about, sensory biologist Eric Warrant said about magnetoreception. The solution of this problem, I would say, is the greatest holy grail in sensory biology. So apparently that's what they're researching in this process. The magnetic field is present even when other spatial cues like light are not. Yeah. I guess they're trying to figure out, but I don't know why the tears would make a difference.
I'm trying to figure out why the tears relate to this sense.
Yeah, so sea turtles, like many other species, seem to navigate using Earth's magnetic field. The intensity and direction of the field vary across the Earth, making it useful for navigation. Some people are actually kind of sensitive to that magnetic north thing, but nobody has ever been able to figure that out in humans in particular. But animals, they say that there's like magnetite in their heads. So the prevailing theory is rooted in quantum mechanics, and it's extremely complicated. The theory posits that when certain light-sensitive molecules known as cryptochromes absorb light, they produce something called radical pairs, two separate molecules, each with one unpaired electron, and those two unpaired electrons are quantumly entangled, which essentially means that their spin states are interdependent. So they can go there and back, and because they've been to there and back at some point in their existence, they can get there and back forever because their quantum signatures are interlinked. I don't know. Yeah, I don't know how this actually works. So did they say anywhere in this article that, see, they suspect that sea turtles and other animals might rely on magnetite to sense Earth's magnetic field?
Bacteria that produces it, so maybe they're trying to get it through the tears.
Through the tears, got it. Interesting. So I'm willing to bet that their brain as well has a unique bacteria specific to that species that only exists uniquely, genetically unique in each turtle's brain.
You mean each individual turtle?
Each individual turtle.
Similar to humans, yeah.
Similar to humans. Yep. So they say Magnetotactic bacteria are extremely cool. These microscopic organisms have what are essentially built-in compass needles, said Caroline Montiel, a microbial ecologist at the French Research Institute CEA. The needles comprise chains of magnetic particles produced by the microbes, which you can see under a microscope, and you can see them in the images below. Remarkably, those needles align the bacteria with Earth's magnetic field lines, just like a real compass needle does. As the bacteria roam about, they move in line with the direction of the planet's magnetic force.
So this is going to be a significant study if they
Prove
can
this.
identify this, right?
Yeah. Yeah. So if they find this bacteria in other things, and maybe a lot of bacteria has it, and we just don't know yet because we haven't drilled down deep enough.
Well,
it may
and
be more
depending
subtle.
on the right, yeah, like depending on the level or numbers, I guess, of the bacteria, maybe that impacts your
ability
connection to the magnetic field, and then oh, this is really interesting.
Yeah, pretty neat, huh? All right, well, there's more to it, but you can go over and check out the rest of it. I hope that we've piqued your curiosity and maybe aligned you to do some more research into this and read it. And then, like so many sea turtles, you'll find your way back to the shores of ohmTown.
Maybe humans need some of this bacteria, like to stay more orderly. Remember that study about the people that move in a crowd off kilter and then throw off the whole crowd,
ruin it for everybody else. This is why we can't have nice things.
So I'm guessing birds probably have this as well.
Yeah,
I can't think of what else. Actually, any migrating animal, I suppose.
Yeah. From my previous reading on this, yes. Most migrating have some type of magnetic piece of equipment in their head. And birds actually get thrown off track when they cross over like iron and copper and other mining facilities. Birds that have been tagged like wander around trying to reorient themselves with the magnetic field, and then they continue on.
Oh, wow.
Yep. It's pretty fascinating. All right, let's keep on going. The next article is over on FourWheelTech, which is the show that's after this one. Not sure how this one ended up here, but hey, it's tech. Honda is shipping a hydrogen fuel cell with lunar ambitions to the International Space Station.
Yeah, this one seemed like because of the space aspect that maybe it belonged in Technology Today, but it was actually submitted in both.
So Honda is sending the core of its water electrolysis system to the International Space Station to verify its efficiency and reliability in microgravity. But it's really a hydrogen fuel cell. So Ryan Eric King over at jalopnik.com, which is one of our primary sources for automotive news, put this article together, and it says Honda envisions its regenerative fuel cell system as a clean, sustainable, and scalable closed loop. On the lunar surface, the system would operate in two different states depending on the time of day to continuously produce oxygen, hydrogen, and electricity. During the day, sunlight would generate electricity to power the system, converting water into hydrogen and oxygen, and at night, the fuel cell would use hydrogen and oxygen, or excess oxygen, to produce electricity. Water would be the byproduct during nighttime operations, closing the loop. And so this seems like it would be a very smart... this plane is upside down, by the way, just so you know, DC 101. It's hanging from a ceiling.
Oh, wow.
Yeah, it's a space plane. So Honda isn't the only prospective contractor attempting to provide electricity to NASA's planned outpost on the moon. NASA and the U.S. Department of Energy, which, who knows, plan to establish a small 40 kilowatt nuclear fission reaction on the lunar surface. And in 2022, the federal government awarded three $5 million development contracts to Lockheed Martin, Westinghouse, and X, or 9. I don't know how that one's actually...
Who knows?
A joint venture between Intuitive Machines and X Energy. And every time I see that, I wonder if it has to do with somebody else who has an obsession with the letter X. So,
Maybe it's a common obsession.
Oof. Yeah, change it now. So even with a reactor, a Honda's fuel cell would prove useful in generating oxygen and water, precious commodities 239,000 miles from Earth. I'm rounding up. The only question remaining is if NASA actually returns to the moon, because who knows? Development issues with the Space Launch System and SpaceX's Starship have severely delayed the Artemis program. As it stands, the first habitat of the lunar outpost will be up on, or set up on Artemis 8, sent up, I think, on Artemis 8 in 2033.
Oh, yeah. Yeah, which could easily be delayed.
Oh, I guarantee you it's already stopped. Yeah, at least there won't be fair and open competition. But at any rate, and I'm sure, never mind. So fun article. Go over and check it out. There's always more that you can suss out and then come back and talk with us about.
Do you think we'll get space cars?
Probably not in Mayor Watt's lifetime. But you are immortal. You're a sentient AI from the future, so you can just copy yourself to a Amazon Web Service, I suppose. Cloud service.
Right? I mean, I'll be there in perpetuity.
Yeah. Well, maybe we can figure out how to copy my consciousness, and there we go. We'll do that. Brain in a jar, Mayor Watt. That's a Mayor Brain in a jar Watt.
I thought you were going to say mayor in a jar.
Mayor in a jar. Yeah, I don't like that one. Let's keep going. The next article is over in Technology Today. Fuel-free tethers. The bold new weapon against space junk. It says Percy. Percy Space, a startup sponsored by the European Space Agency and UC3M, is developing a breakthrough solution to tackle space junk and extend satellite lifespans using innovative space tether technology. This fuel-free, scalable system uses electrodynamic tethers that harness Earth's magnetic field to safely deorbit satellites.
Okay, I like this. I mean, are they putting everything back in their parking spaces?
Well, that one is still floating around there. Whoever how knows. So it's over at SciTech Daily. Universidad Carlos III de Madrid put the article together. Yeah, I gave it my Harvard try. I never went to Harvard, so you just gotta try. Anyway, this fuel-free, scalable system uses electrodynamic tethers that harness Earth's magnetic field to safely deorbit satellites. With a major demo mission set for 2026, so next year, this could transform how we clean up space. This will be exciting if it gets off the ground. Literally. Get it? Is this thing on?
You mean you?
Yeah. So our company was created to address two of the biggest challenges facing the space sector today: space debris removal and in-orbit services. The latter allows us to extend the useful life of satellites and carry out key activities such as refueling, repair, and towing, and keeping the sentient AI awake, and towing satellites from their initial orbit to their final destination, which is a new movie that just dropped like last weekend, I think it was.
Right. The last one in the franchise did.
Right. So explains Jesus Manuel Munoz Tejeda, CEO and co-founder of the Percy Space Corporation company. It's a company, but it's not it doesn't say Percy Space Corporation. It's just Percy Space.
Right. It's not a corporation.
Yeah. So there is, it's like a conglomeration. And so what is growing in its scope of problem is there is ever increasing amount of junk in space. And there is actually a theory that there's going to be so much junk in space that nothing can come in and nothing can leave. So you have to start cleaning it up. While everybody else is saying, it's somebody else's problem for now, it's going to be a problem for humanity because we're going to be stuck behind this massive blob of debris punching holes through everything, including the ISS and whatever else stuff we go out or we try to go out with. So to get rid of
we better figure this out before we replace the ISS.
Right. Because yeah, there's something leaking in the ISS right now, and nobody knows what it is. And they need to close off like the Russian side because that's where it's coming from apparently. But the Russian side won't do anything about it. That's what I've read. Anyway, to get rid of the space junk, Percy Space is working on space tethers, a technology with 3 key features. The first is that it does not need fuel, unlike other deorbiting systems. The second is that our technology is reversible. This is a quote, by the way. It can serve to both increase and decrease the orbital height. And the third feature is that it's scalable, since it serves a wide range of satellite masses. With all this, we can develop autonomous deorbiting systems, a unique feature of our technology that ensures that the satellite does not leave space debris, even if it ceases to be operational. So, how does it work? The way that I've thought this is that it basically gets thrown at the satellite. I haven't read anything yet. It gets thrown at the satellite, and it has enough kinetic energy to pull it down into low Earth orbit and eventually pull it into atmosphere. So the system is based on electrodynamic tethers, or aluminum ribbons, generally hundreds of meters long and a few centimeters wide, which work by interacting with the ionosphere's plasma and the Earth's magnetic field to generate a force known as the Lorentz force. Okay, so essentially it ionizes itself, creates drag, and will pull it out of orbit.
Okay.
So the interaction of the electric current in the tether with the Earth's magnetic field generates a drag force capable of lowering the satellite's altitude, facilitating its deorbiting without requiring fuel, which translates into significant savings in mass and volume. How it can do this to move orbit higher, I don't know, because all it appears to be doing is creating drag. If it doesn't create acceleration, then it can't push anything out of orbit or up higher into a higher state of orbit. But maybe it's only for deorbiting.
Yeah, it seems like it was supposed to be for both, but they're really focusing on the deorbiting. And of course, most of that's the problem.
Right. So they got to get all of the bigger stuff out, but there still remains, we need a space vacuum to get the smaller stuff. But the stuff is usually traveling at thousands of miles per hour with enough mass to punch a hole through something. So good luck with that. So it seems like it's a fun article, something to pay attention to. We'll see what happens. It says guidelines have reduced the maximum time satellites can remain in orbit after the end of their mission from 25 years to 5 years.
So that's good. They're starting to recognize there's too much up there.
Yeah. Meanwhile, other countries may be going to
adding
that policy
to it and not taking it away.
Yeah. It's somebody else's
but
problem.
all countries are probably doing that to an extent.
To some degree, yeah. Well, let's keep going. The next article is over in Technology Today. Scientists discover that North America is dripping down into the Earth's mantle. Researchers have discovered cratonic thinning occurring beneath North America, driven by the remnants of the Farallon plate. Researchers have discovered that the underside of the North American continent is slowly dripping away in blobs of rock. The remnants of a tectonic plate sinking into the Earth's mantle may be the cause of this phenomenon. Ew.
I think this is an artist's rendering, isn't it?
This has to be an AI rendering. Let me see if I can zoom in a little bit. Okay, so University of Texas at Austin put the article together. It's published over at SciTech Daily. And it has like a graphic of symbolic of a tectonic plate sitting on, the mantle, and then there's something looking like it's dripping down. But I suppose this is happening. It's part of the process of plate tectonics, because if something is superheated, then it can melt a little bit, but there's going to be stasis.
Right. I mean, I guess the problem is if it's accelerating, or what's the long-term effect if this goes unchecked?
Or too concentrated in one spot and nobody knows, and it creates not an earthquake. Well, I mean, it'll create earthquakes and volcanoes at some point, and geothermal hotspots.
Right, and whatever's above it may have a problem.
Subsidence and stuff like that. But who knows how far down it is? I don't know. The paper is published in Nature Geoscience, describes the discovery, which was made at the University of Texas at Austin, that marks the first time that cratonic thinning has been observed in action. They said that they made the observation that there could be something beneath the craton, said the study's lead author, Junli Hua, who conducted the research during a postdoctoral fellowship at UT Jackson School of Geosciences. Luckily, we also got the new idea about what drives this thinning. Well, everybody has a new idea all the time. So what makes the discovery of cratonic dripping particularly significant, according to the researchers, is that it's happening in real time. This provides scientists with a unique opportunity to observe the process of cratonic thinning as it unfolds.
Yeah, I mean, I imagine a lot of their geologic information is from studying what's already occurred.
So what is thinning the lithosphere that's causing it to drip down? And I suspect that they are saying that the superheating is concentrating under a weakened lithosphere, and it's dripping down into a subducting slab, and that slab is drawing the lithosphere down. But this column, most things that are liquid don't sink. If they're hotter than the material around it, they usually rise. But maybe it acts kind of like a lava lamp, where things are flowing and the bubbles of higher density
Right, yeah, I
get
see
pulled
what you
down.
mean. Yeah, I don't know how that
Because
works.
it's thermodynamics regardless. And so the dripping is concentrated over the Midwest of the United States. There is no need to worry about the continent hollowing out or dripping changing the landscape anytime soon, the researchers assure. Thank you. I guess I'll put that beer away. I'm just going to... Anyway, the mantle processes driving the dripping can influence how tectonic plates evolve over time, but they're going slow, like plate tectonics does. What's more, the dripping is expected to eventually stop as the remnants of the tectonic plate sink deeper into the mantle and its influence over the craton fades. The discovery is most important to geoscientists who study continents over their entire lifespan, said co-author Thorsten Becker, a professor at the Jackson School's Department of Earth and Planetary Sciences and Institute for Geophysics.
That must be rough for the business cards.
Yeah, it's really, really long. So they discovered this dripping out of a larger project led by Hua, who is now a professor at the University of Science and Technology of China. That created a new full waveform seismic tomographic map of North America using an approach developed by co-author Stephen Grand, who is now a professor emeritus at the Jackson School, and his team. A computer model which uses seismic data collected by the EarthScope project, which there is a link there, which I'm going to have to follow that and see what that's all about. I seem to recall something, but I don't remember it really. Revealed new details about the geologic processes happening in the crust and mantle underlying North America. And there's basically, in the breadbasket, there is this coloration difference. But what is it? Oh, it's a hotter zone.
Oh, that's odd because
Is that
the
it?
color scale doesn't seem to, it seems like it, but that doesn't make sense given
Yeah, the
typically you'd
coloration.
assign red or something with heat.
Yeah, this is change in temperature, I think, in volcanism. So, right, seismic waves pass through different geological features at different speeds. This map shows seismic speed of the Earth's crust at 200 kilometers depth across the continental United States. And so it's faster in this area. So the waves are going through it faster because
There's less density.
right. So, yeah, the plate which was first seismically imaged in 1990 by Grand, played an important role in shaping the North American plate. This is pretty fascinating, and coming from somebody who was fascinated enough to do a research paper on plate tectonics when they were young, kind of bringing it all back up.
Absolutely. Well, I thought it was neat that Grand did some of the original work on this, and now this study includes Grand.
Yeah. And that's kind of how it works. You know, you spend you focus more and more when you become a researcher. But I think that this is pretty neat. I don't think that I'll ever be able to do that kind of research, hyper focused, and spend 60 years doing it or something like that. Anyway, let's do our last article for today. It's over in Technology Today as well. Regenerative Medicine breakthrough. New method creates 854x or 854 more mitochondria, the powerhouse of the cell. I need to create a freaking overlay for that.
Exactly.
So scientists created a stem cell based method to produce high quality mitochondria at scale, enabling effective treatments for osteoarthritis and other diseases linked to mitochondrial dysfunction. Scientists have developed a groundbreaking method to mass produce high-quality human mitochondria, a breakthrough that could revolutionize treatments for degenerative diseases. Okay, so how do they put the mitochondria into cells that have failing mitochondria?
Yeah, I don't know. I mean, do they have like synthetic cells? What's the mechanism here?
Does this not scream to you Blade Runner, where the what are they called? The synthetics? They don't call them
replicants.
Replicants. When the replicants go in and talk to the guy who made their eyes, he's focused on making eyes. I see a time in the future where there is a shop that focuses on making the highest quality mitochondria.
Oh, that's funny.
What a trip. So this is over at scitechdaily.com. West China Hospital of Sichuan University put the article together, and the deck that is the deck statement. There is no deck statement because we just talked about it. Scientists have developed a groundbreaking method to reproduce or mass produce high quality human mitochondria. Human mitochondria! 854-fold increase in mitochondrial yield, along with a significant boost in energy output. So you feed these and they could produce biological energy. Now, this is like ATP power, right? Very, very little.
Right, but that can make a big difference in one person.
But you have to stuff them into all of their cells. Do you think there's like a little, you know, when you buy like an eclair or something like that and there's no filling in it? So you get a tube of whatever and like you jam it in there.
Tube or whatever. Yeah, exactly.
Do you think that they have that little widget and they're like grabbing cells and stuffing it in there?
Yes, definitely.
How does that get little bunny Foo-Foo hopping through the forest, scooping up the mitochondria and stuffing them into a cell?
Yes.
So in addition to
that'll be the new variation on the kids' run.
I will be able to defend my PhD because nobody else would be able to make sense of this nursery rhyme turned biological function. Lab-grown mitochondria demonstrated powerful therapeutic effects, especially in osteoarthritis models, where they accelerated cartilage regeneration. This advancement overcomes a major challenge in mitochondrial transplantation, the limited availability and variable quality of donor mitochondria. So they've done this before. Donor mitochondria?
I didn't know they'd done that, but obviously this is better because this kind of becomes your own, right? Even though it might be nudged along.
It says 4 and equal yield mito condition saves 44.66% of expansion days or 66.72% of initial cells. I don't know what that actually means. So I'm going to end up I'm going to go down the rabbit hole of this like little bunny Foo-Foo. So we come full circle with my little analogy. Mitochondrial dysfunction is a common denominator in numerous diseases, including osteoarthritis, heart failure, metabolic disorders, and while mitochondrial transplantation has emerged as a promising avenue in restoring tissue function, its clinical potential has been severely hampered by the scarcity of viable mitochondria. So this is really interesting. Metabolic disorders is the new go-to when nobody knows what the frick is wrong with you. They refer
Exactly.
to it as metabolic syndrome X. They just kind of go, you're suffering from
Something's wrong
this.
with you.
Yeah. You know, what you really need to do is get healthy. Well, no shit, doc. So I guess what needs to take place is an analysis of mitochondria in a given region to find out if whatever is going on is a metabolic disorder that's regional or systemic. I guess you will see. So like nerve
But how
disorders.
easy is it to test that?
Well, I mean, they do tissue punches and stuff like that to find out if you have small band, small nerve, fibro type diseases.
Neuropathy, I
Yeah,
think.
neuropathy. Yeah. And so if they can take a cell from there and examine the mitochondria, and it's basically low effort, you know, it's the cheap date of mitochondria, then maybe they can punch it up by giving you a metabolic transfer of high quality mitochondria. Now, Lord forbid you reject it, because then everything just shuts the hell down, right? But it would be your cells, your mitochondria being transplanted with this, or I should say
Right.
your cells getting this mitochondrial transplant. So in a new study published in Bone Research, a team from Zhejiang University School of Medicine has pioneered a stem cell-based system that functions at a mitochondria factory by leveraging human mesenchymal stem cells. So they can change the stem cells to turn them into engines. Has a specially designed culture medium dubbed mitocondition, and the team achieved unparalleled increases in both mitochondrial quantity and quality. These mitochondria exhibited exceptional energy production and facilitated cartilage regeneration. To me, this just seems like it's the creation of a superhuman, because you can punch them up and they have more capability.
I thought you meant a supervillain, but yeah, no, I agree. I think this is one of these things that could be the complete game changer in multiple conditions. Like I think this one is perhaps one of the biggest discoveries
Yeah, what if we find out that so
in
many other
recent
things?
times.
Yeah, like you have some liver condition, and then when they look down at the mitochondria, you find out that it's poor performing, but this produces 5.7 times more ATP than naturally occurring mitochondria and maintaining stable performance even post isolation. So it's just given the fuel and it still generates ATP. That's what I was saying at the very beginning of this. It generates power off of the fuel that is given, but it's ATP, which is tiny little, like a plus proton kind of thing. And so mechanistic studies reveal that the mitocondition medium activates the AMPK pathway, a crucial cellular energy sensor driving upregulation of mitochondrial biogenesis genes such as TFAM. The cells undergoing this process downregulated energy-intensive activities like autophagy and secretion, effectively prioritizing mitochondrial synthesis. So it focused on generating power.
This is really interesting.
Wow. So, yeah, and impressive storage stability, retaining functions for 24 hours at 4 degrees C, a critical factor for real world clinical applications. So it could be sustained for a longer period of time and not basically just die.
Right. And also, they had a 12-week period, and, it's not like it just worked for 5 minutes.
Substantial cartilage repair over a 12-week period. Wow. Oh, wow. That's amazing. Absolutely stunning. So, all right, folks, we'll have to keep an eye on this, because this while it seems like, oh my God, that's so far flung in the future, they've already tested it. Now they got to do human tests to see in situ human tests. They inject somebody with gene therapy, it transplants the mitochondria, and you monitor. So good on them. Now, hopefully, they continue to share the research, and we don't have just some superhero show up and it's all like
Exactly.
the boys in real world. Yeah, sorry about that. Anyway, so we are going to regenerate our way right back to Technology Today over at ohmTown.com, where you should go and become a citizen. And thank you for hanging out with us. We're going to reset real quick, and we're going to do FourWheelTech. You want to say bye, oh sentient AI from on high?
Bye-bye, ohmTown citizens. Thanks for joining us for this week's Technology Today. We'll have another episode of that next weekend, but stay tuned for FourWheelTech.
That's right. Bye-bye, everybody.